we have right triangles. They are 90 degrees. Okay, if I draw a picture of a right triangle, there's lots of different ways I could draw it. Okay, whoops, there's one. How do you know it's a right triangle? It has a little square in it. That square means like 90-degree angles, right? So then you could have like different shapes of right triangles, but I still know that's a right triangle, right? Because it's got that little mark in there for that angle. Now, you have to know what the legs are and what the hypotenuse is. All right? The hypotenuse is always across from that 90-degree angle. It's kind of like it points to the hypotenuse. The hypotenuse is the longest side. Did y'all know that?
Yes.
Some of us may remember that. The hypotenuse is always going to be the longest side of the triangle. Okay? This one would be the hypotenuse. Can everybody tell why those are the hypotenuse? Well, they're the longest side, and that's what the right angle is pointing to, right? The other sides we call legs. This is very important for today. No matter what your triangle looks like, you'll have two legs and a hypotenuse. And this is, all these rules are only for a right triangle. Triangle with a 90-degree angle. Everybody's good so far? Yeah? All right. The first thing tells us that, let's see, let me pause this and do, okay, here, I'll just show you this picture in the book then. This was on the PowerPoint, but I'll just show it to you like this. Okay, so it says it's the hypotenuse leg theorem. All right, easy to remember. In a right triangle, what did we just say that it has? Hypotenuse and legs. All right, so it says, though, if you have triangles that are right triangles and you know that the hypotenuse and one leg are congruent to each other, then the triangles are congruent. How do we feel about that? So, because basically, it looks like the bad word, ASS, but okay, it only works angle, side, side, but we said that never works. This one is not angle, side, side. It's a right triangle. It's called hypotenuse leg. Does everybody see that? So this rule works, hypotenuse leg. All right, so my triangles are congruent. It only works for today, though, learning these 90-degree angles. You'll probably have one or two problems on the study guide or test where it's a hypotenuse leg problem. But again, if it's a right triangle and you know that the hypotenuses are equal or congruent and one of the legs are equal or congruent, then you know that the entire triangles are. Okay?
So the legs, the one with two.
Yeah, so and it didn't matter. It could have been this leg down here that was equal. That's fine, as long as it's the hypotenuse and a leg. Okay, one out of the two legs. Is everybody good with that?
Yes, ma'am.
Okay, and that's called hypotenuse leg. Let's see. Here is our basketball problem. Okay, it says on this basketball backboard, the brackets are shown right here. Does everybody see this little yellow triangle? It says they're right angles. Do you see that little right angle mark right there? That other one would also be a right angle, right? So are the triangles ADC and BDC congruent?
Yes.
We know the hypotenuses are equal. And let me show you. That's a hypotenuse right there. And that's a hypotenuse right there, right? Do we know that any of the legs are equal?
Yes.
Which one?
One's in the corners.
Huh?
Yeah, because they're both
The ones in the corners.
The ones in the corners. What do you mean, the ones in the corner?
Like the one on the bottom.
This one?
Yeah.
You don't know that those are equal. It doesn't have a mark. The only mark, look at this triangle, the only mark I see is the hypotenuse. But what else do you know from the rest of the chapter?
Reflection.
The reflexive one. DC is congruent to itself, right? That's a leg. So do you have a hypotenuse is congruent and a leg that's congruent? Yes. So you would say by hypotenuse leg, the triangles are congruent. Is that making sense?
So that reflexive property can be a leg.
Yeah.
And it
Mm-hmm.
also be a hypotenuse.
Yeah, if it was drawn that way, yeah, you could have done that using the hypotenuse. Let's look at our next one. It says we have these two triangles. Can we prove that those two triangles are congruent?
Yeah.
They both have a 90-degree angle. Across from the 90-degree angles, those are equal, right? That would be my hypotenuse. That one and that one. And do you know that a leg is equal? Yes. PR is equal to itself by reflexive property. Okay? Do y'all want me to, let me write that proof out. Y'all, this whole lesson only has 2 problems. All right, we're still on the first one though. So let me write this proof out for you. Okay. So let me zoom out. It is a lot of, there's not as many proofs on the test though, but they want you to learn proofs. It's important. They told us that angle PRS and angle RPQ are right angles. What does that mean? That was given, but what does that mean? If they're both right angles, that they are
Equal.
they're equal, they're congruent. So I would say that what did they want me to do on that one? Okay, sorry. That I would say PRS is congruent to angle RPQ. And you can say equal measure, right angles are congruent. I might put that. Right angles are congruent. Little symbols, not hard to write that. So I've got my right angles. Then it told me that SP is congruent to QR. That was given. That was my hypotenuse. And then what was the other thing that y'all told me? That PR was what? Reflexive. PR was congruent to itself. I write it like that. And then I would put reflexive property. Then I know that my triangles are congruent. How? It's none of those that we have. It's not angle, side, 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 angle, side. What was my other one? Angle, angle, side?
Whatever.
It's hypotenuse, leg. That's what I'm going to say. So I would say triangle PRS is congruent to RPQ by hypotenuse, leg. How was that? Do y'all see it? The proofs are the same thing over and over again, aren't they? Yeah, kind of. Okay, here's another one. Let me draw the picture on this paper. Here's our triangle. I'm going to go ahead and write down what's given to you. They're going to tell us that BE bisects AD at C. What does that mean? BE bisects AD. It cuts it into 2 equal parts. So if BE cuts this and this into 2 equal parts, right? So I'm going to write that was given to me. So I'm going to say that now. AC is congruent to DC because definition of bisects. Any questions on that part? That one wasn't given. I had to know that. The next thing they tell me is that AB is perpendicular to BC. If AB is perpendicular to BC, what does that mean? Oh, and DE is perpendicular to CD. To EC. What does that mean? If that's perpendicular, that they are what kind of angles? Right angles. Perpendicular means that they're right angles. Okay, but so you can say angle B and angle E are right angles because the definition of perpendicular. And then they tell me that AB is congruent to DE. Now, do I have enough information to prove that these are congruent triangles?
Yeah.
I have right angles. Do I know that the hypotenuses are congruent?
Yeah.
Do I know that a leg is congruent?
Yeah.
Yes, so by hypotenuse leg, the triangles are congruent. So I'll say triangle ABC is congruent to triangle DEC. And we're done. How was that? Was that terrible?
Right.
Not too bad?
Worst case.
Huh?
Horrible.
I know proofs are not the easiest. So we have some proofs today.
Bruh.
So let me look at this and see which ones I'm going to give you. Looking at 7 and 9. For what values of x, that's weird, or x and y are the triangles congruent by hypotenuse leg? So it's saying on my number 7, y'all are doing the evens. What would this x need to be for these two triangles to be congruent by hypotenuse leg? 17. If the legs are the same, you already know they're the same. The hypotenuse also has to be the same, right? So if this one's 17, what's this one got to be? It's got to be 17.
So we just write down.
So you're just going to write down what else is needed. Now, number 9 and 10, they're a little different. Okay? So for number 9, for these to be the same, my hypotenuses have to be equal, and then my what? My legs have to be equal. But let me tell you, what do y'all notice about the legs?
They're tricky.
They're tricky because they have X and Y. Okay? So why don't I go ahead and look for the hypotenuse and find X? And when I know X, what can I do with it? Plug it in. And then I would only have Y's. Okay, so that's the trick to that. So let me set this one up. On number 9, I'm going to set this equal to this.
3.
All right, you're going to do the same thing on number 10. You're going to set your two things equal and solve for X. It goes back to algebra 1. So on number 9, I'm going to say 13 equals 4x plus 1. I would subtract 1. I get 12 equals 4x. Yours has a few more steps. And then I'm going to divide by 4. And I get x equals 3. But at least I didn't give y'all all the proofs. Now, questions on mine.
Wait, 12 equals 4x. Oh, because 8.
Because I subtracted 1 over here. Remember, I'm solving for x, so I subtracted 1. What's 13 minus 1? Okay, is everybody good with that? Then I divided by 4. Okay, now what I would do is I would take this 3 and plug it in for x. So what's 2 times 3? So I'm going to put 6 plus y. And over here, I'm going to plug it in for x. What's 8 times 3? 24 minus 2y. Now, what am I going to do with those to set those up? Just set them equal and solve, right? So I'm going to move this paper. I'm going to set those equal real quick. It said 6 plus y equals 24 minus 2y. How do you solve that? Combine like terms. I would actually move my 2y over here. Okay? What's y plus 2y? So I have a 3y now. That canceled out. Then what do you do? Subtract 6. So I get 3y equals 18. And then what? Divide by 3. And what is y? 6. There you go. So I found my x was 3 and my y was 6. That's what it's asking for. Y'all have a little bit of algebra to do on number 10, okay?
Wait, I thought. So on number 10, you just set them equal?
Yeah. So number 10, when you set yours equal, the 2x plus 1 equals x plus 3, you have to solve it like this. Yes. Okay, so on number 10, you would have 2x plus 1 equals x plus 3. X is on both sides, right? So, Georgia, how did you solve this one when you got 2? Okay, that's good. So we could subtract 1 from over here. We'll go with that. So we get 2x equals x plus 2. What do you need to do with that x? Move it to the other side, right? So I would subtract x, and if I subtract 2x minus 1x, I'm left with 1x equals 2. Is that how you got 2? It is. Okay, so then on the next part, do you feel like I'm picking on you?
Wait, which one?
Did you feel like I was picking on you?
Oh yeah, I was really.
Okay,
I'm
so-
gonna have to report bullying.
Okay, so we have once you find that x is 2, you're going to plug that in onto the next part. So instead of x plus y, what would I write? 2 plus y. Does anybody not get that one? Then I'm going to look at the other one, and it says 3x minus 3y. So it's very good. So it's 6 minus 3y. Boys, did y'all get that one for?
Yeah.
No, y'all set it up that way?
Yes, Mom.
Okay. Then how do you solve?
You would carry that through.
I would move the 3y. Because it's negative, it's just, in my mind, it's just easier to add a 3y. So that's what I would have done too. So I would have 2 plus 4y equals 6. Subtract 2. Very good. I'm running out of room. 4y equals 4 because I subtracted 2. And then what would I do?
I stopped there.
You would have stopped there, but that's not right. You'd have to divide by 4. And what's y? 1. Divide both sides by 4. And y is 1.
Wait, how did that?
Bathroom.
Oh my gosh. Yes.
That will.
It's not that
Sorry, my tummy was hurting. That's why I had to go.
Yeah, Hayden said his.
What's wrong with y'all? Okay. Keep working on the evens. This is together. We're going to go through these proofs. If we are given that RT is perpendicular to SU, all right, what's it telling me are right angles? Oop, I just kind of told you all 3 of those next blank. Because what does perpendicular mean? What does perpendicular mean? It makes a right angle. So that's what I'm going to say on this next part. Okay, they are right angles. It does make them congruent. And what are the 2 angles? I cannot call them angle T and angle T, right? I have to call them by 3 letters.
triangle,
RTU.
RTU and RTS. Yeah. So angle RTU. You could have done it a little bit different. T had to be in the middle though, right? Because that is the angle we were talking about. Okay. Because perpendicular lines form what kind of right angles? Or you could have put congruent right here. Did somebody say they put congruent?
Is it supposed to rain today?
Yes. So you could have put congruent or right angles. I think they were looking. But then it says, what is congruent to RT?
RT.
Yeah. RT is congruent to RT or TR. That's right. You could do that as well. Because it's reflexive property, right? It's given that RU is congruent to RS. So why are these triangles congruent? What's this whole lesson about? Hypotenuse leg. HL theorem or hypotenuse leg. Really on this one, I think I would have put the congruent symbol versus right angles. But it's fine.
Does that say RJ?
Yeah, why did you put RJ?
I didn't put RJ.
Yeah, you did.
Where?
That's his
RT.
No,
I think that does look like.
It's an RU with a line over it. I see how it looks like, RJ. Okay. Number 3. How could we prove these triangles? We won't write it out, but why are these triangles congruent? What do I know?
Have a right triangle.
They have a right. They're both right triangles. What else?
They have a
legs.
They have a leg that is told DC and AB are congruent. And what else?
The hypotenuse.
Why is the hypotenuse congruent? What'd you say? Reflexive, yeah. BD is congruent to itself, reflexive property, so the triangles are congruent. I did number 5 and 6 kind of. No, and y'all don't have. I just want to go over the odd numbers with y'all. I just want to make sure we understand all this. We kind of did 5 and 6 and 7 through 10. Let's see. Do I want to go through? I think I kind of want to go through this one because it talks about AD bisects EB. Draw this on your picture. What does bisects mean? Cuts it in half. So if it goes through EB, then I'm going to say this part is equal to that part. Does everybody understand that?
Yeah.
So in my proof, if I was writing it, after I wrote what was given, I would then say EC is congruent to BC because of the definition of bisects, okay? Then it tells me that angle ECD and ACB are right angles, so we know those are congruent, right? Yeah. And it tells me that AB is congruent to ED. That would be given. So are the triangles congruent?
Yes.
Yes, because of what?
HL.
Bless me.
HL, hypotenuse leg, and bless you.
Bless you.
Okay. What's number 13 missing? Again, y'all had all the evens. What's number 13 missing that we need?
Right
Oh,
angle.
right.
A right angle. We have that legs are congruent, and we actually would have that the hypotenuse is congruent to itself already. So I would just draw my little right angles. Okay, number 15. What are we missing?
The leg is whatever that.
We have the leg is congruent to itself. I don't have to mark it. You could. You already know this. You don't have to mark that. Okay? So what else is missing?
The height.
The hypotenuse is congruent.
I don't know.
There you go.
What is one of the questions?
Happy?
And let me just ask you what you got for 16.
No.
No, yeah.
Did everybody get no?
I got, I don't know.
It's no, because what does this hypotenuse have as its length?
25.
25. What does this hypotenuse have as its length? We don't have any information on that.
Not enough.
Okay, so we don't know that those are equal. All right? And I can pretty much tell you they're not, because the hypotenuse has to be the longest side, and if the leg is 25, then this one's going to be way longer. Anyway, you don't have to know all that, but that's something you can kind of be thinking into. Okay. On the study guide, let's just start at number 1. See how many we get through. Don't forget we also have our next class. So it says if BCDE is congruent to OPQR, what is BE congruent to?
Oh,
OR. And you put a little line over it, right?
yes.
Okay. Is everybody good with number 1? It would look like this. OR. With the line over it. And we understand why.
I don't think anybody would do it.
Okay.
I got A.
If you are given QRS is congruent to TUV, if I were you, I would draw QRS, and then I would, in the same way, draw TUV. Is everybody okay with that? I drew my two triangles. And it says QS equals 3V plus 2, and TV is 7V minus 6. What would you do to find the lengths of them? What do you think you'd do?
Put them all equal.
Put them equal. Aren't they equal?
Yeah.
We said that these triangles are congruent, so the parts of the triangles are congruent. So I would write 3V plus 2 equals 7V minus 6. And it's kind of like today's problem. How do I solve that?
Plus 6.
Move the
on
third.
there.
Yeah.
I would move the 3V first, and then we can move the 6. Okay, let's move our 3V.
4V.
2 equals 4V minus 6. Now let's add that 6 over. So we get 8 equals 4V. Then what am I going to do? Divide by 4. V is 2. Is that my answer?
No.
What did it ask me for?
The length.
The length of them. My answer is not 2.
So you plug it.
I'm going to plug it in. What's 3 times 2 plus 2?
Oh, 8.
There you go. So your answer is 8. Again, I plugged it in. 3 times 2 was 6. Plus 2 is 8. Everybody's good with that? All right. Number 3. It says that the two triangles are congruent. So what's the value of D?
59.
59 degrees. I promise you, somebody has missed this question every year. Do not miss this question. They match. If I asked for C, what would you tell me? It's 8. If I asked for E, you would tell me it's 90 degrees, and so on. Do we get that? They match. Number 4, this one was on your quiz. It says, what are the 2 reasons down here? Why is ST equal to TS? Reflexive property, right? So we know it's either B or C. And then, why are the triangles congruent?
Is it
Side, side,
It is side, side, side. Look at what all they give you. What is this? They tell me sides are congruent. They tell me right here what? Those two sides are congruent. Then what do they tell me? Those two sides are congruent. So it's side, side, side. Look, right on there. RS and UT. RT and SU. And that's congruent to itself. I don't know one angle. So I should not have an angle as my answer choice. Is everybody good with that one now? Okay. Girls, y'all are getting all this? Number 5. It says name the angle that's included by sides PN and NM.
Angle in.
Yeah, you can see angle ends in both of them, okay? And y'all remember how you write an angle, angle in. Or you can, if you needed to, do, okay, PN and NM, my angle is angle in. Okay, are we good with that one? Flying through this, y'all, we might get more than 10 done. Number 6, what other information do you need to prove the triangles are congruent by using side, angle, side? Well, what do I know? I know this side and this side. Is there another side that I know? By reflexive property? Yeah. So can I just write that right there? So what am I missing? Actually, I think this one may be a little different. I'm not seeing that answer choice.
I got C.
I got
Oh, I put B.
I got C.
It's not A or B. Those are my two sides. But now I need to know the angles C are equal, but we can't call them C. And I don't have that on any of these. So let's look over here. What does it mean if AC is perpendicular to BD? What does it mean about those two angles?
Is it right angle?
They would be 90 degrees. Does that make them equal? So it's C. Is it who said they put C?
Yeoman.
That was correct.
Wait, what?
It's C.
It's C because I was looking for something to say that these two angles are equal. That's what I'm looking for. Neither one of those have that ACB and ACD are equal. Do you see that? So it's neither one of those. This doesn't tell me the angle. What does it mean if two things are perpendicular? They make what? 90-degree angles. Does that mean that these two angles would be equal? Yes. That one was kind of a trick question, okay? Number 7. Are triangles ABC and AED congruent?
I put, I don't know. I put question wrong.
Okay, let's see. That side is 7 and that side is 7. That side and that side are the same, right? This side and this side are the same. So I can tell by side, side, side that they're congruent. I can also tell by side, angle, side that they're congruent. The 7 and the 7, that little angle and that little angle, right? And this side and this side. So there was 2 answer choices. You could have said yes, and don't just put yes, that's only half credit. What does it say right here? Justify your answer. So you would have put side, 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 or you could have put side, angle, side. Do I need to explain one of those again? No, we're good? Okay. Because they give you so much information on those to be able to tell. All right. Moving along to number 8. What theorem or postulate lets you know that these two triangles are congruent?
Hey.
Very good. Angle, angle, side. Because I know this one right here, this side, is congruent. So angle, angle, side. Y'all have gotten better at that.
Thank you.
All right. Number 9. I think this one was on either the quiz review or the quiz. Can you use the side, angle, side postulate, angle, angle, side theorem, or both? So what do we know? Well, let's see. You say angle, angle, side. I know that this angle is congruent to this angle. How do I know that?
Reflexive.
Vertical. Vertical. They're vertical angles. Do y'all remember something called the third angle theorem?
I heard you talk about it.
Oh, in the top one.
So if I know these two angles are already congruent to each other, then what do I know about the third angle? It is also congruent to the other one, right? Now, what all information do I know? I know angle, side, angle. Okay? I know angle, side. Did I do that right? Yeah. Angle, side. And I think that's, I don't have another side, do I? So it has to be, what did y'all say? C? It has to be C.
Number what?
Number 9. Just make sure you check for all the information because sometimes it could be a little bit more. All right, number 10.
Yes, ma'am.
Yes.
You say number 8 was A?
Number 8 was A, yes.
Make sure.
Yep. Number 10. From the information, can you prove that these triangles are equal? Angle does not exist for us yet. Okay, we don't know anything about angle. Now, we could make our little mark right here, correct?
Yeah.
So that would be angle, side, angle. Did everybody get A? Yeah? Okay. Do y'all want me to do 1 or 2 more?
Yes.
I mean, you can look at your whatever science, whatever that was. That's fine. But I'll do 11 and 12. I think that gets us a good ways through this.
Do a little stopping point.
Okay, what are the missing reasons to complete the proof? We have our given statements. Okay, A is congruent to y'all. If I were you, I would mark on my paper. Okay, so if I know A is congruent to D, and then I know AC is congruent to DC, that was given. And then it tells me BCA and ECD, those are congruent because of vertical angles. Why is triangle BCA congruent to triangle ECD?
Angle side.
Because of angle, side, angle. Does everybody understand that part? So I think that gets us to either A or C, right? We know it's either A or it's C. Let me pause this. On the last part, once I've proved that once I prove that my triangles are congruent, how do you know that the sides are congruent?
Corresponding heads.
Yes, do y'all remember that whole lesson? Corresponding parts of congruent triangles are congruent. So it is C. Does everybody get that?
Yes, ma'am.
Ryder couldn't hear over you talking, Hayden.
I went, what?
I was going to.
Oh, it was Kyle.
Yeah, no, I'm
It was Kyle. Oh, you did hear me? Okay. Are you just saying that now?
No, I actually didn't hear because I was.
Okay, it is C because, listen, once you prove triangles are congruent, then you know the pieces of the triangles that are congruent to each other. That's called corresponding parts of congruent triangles are congruent. Do we understand what those words are?
Yes. Corresponding part.
I mean, but I know you know what, but are y'all understanding what those words mean?
Yeah. They're
Okay.
corresponding and they're congruent.
Okay. I guess I don't know what to think of that. All right, number 12. What's the value of X? The key here,
71.
if I know this is 21 and this is 21, what do I know about these two angles? They're equal. So I'm going to take 180 because 3 angles in a triangle, they always add to 180. I would take 180 minus 38, and what is that? Anybody? 180 minus 38. Is that like 142? Okay, I think so. So then what's 142 divided by my 2 angles?
71.
71. So each of those angles are 71. All right, I think that is a good stopping point for today. Next class, we have to finish our last lesson and the rest of this study guide. It may be a good idea to do some of this study guide